Way 71 deals with concentration of solutions and it addresses parts per million. Now, please note that this formula is provided to you on the back of table T. Parts per million just simply means exactly that. It's the mass of the solute or the substance being dissolved divided by the mass of solution, but taken at a per million scale. So we need to multiply this by 1 million. It's kind of like percent, except instead of multiplying by 100, we multiply it by a million. And this tells you how many parts of solute per million of solution if we compare the two masses of the solute and solution. So let's try some problems. Parts per million is used to express. If you said 2, you got it correct because that's what parts per million is. It's representing concentration. You know that the other way to measure concentration is in terms of molarity, and we've already covered how to do that. An aqueous solution has a mass of 490 grams, containing 8.5 times 10 to the negative 3 grams of calcium ions. The concentration of calcium ions in this solution is, notice that all the answer choices are in parts per million, so you're going to have to use the parts per million equation in order to calculate. To find parts per million, you need to find the mass of the solute and divide it by the mass of the solution. Here, the solute is represented by the grams of calcium ions, and the mass of solution is represented by 490 grams. Now that we have the masses of each, all we have to do is take each number and divide it into each other, like so. Parts per million is equal to grams of solute divided by grams of solution times a million. We're given 8.5 times 10 to the negative 3 grams of calcium ions. We divide that by 490 grams of solution, multiply it by a million, and out pops 17 parts per million. So answer choice 3 is correct. The concentration of a solution can be expressed in, if you said answer choice 2, you got it correct. Note that parts per million is just another way of measuring the concentration of solution. And you can confirm this on reference table T. So when it comes to parts per million, it's just another way of calculating the concentration of solution. All you have to do is find the mass of the solute, which is the substance being dissolved, divide it by the mass of the solution, and simply multiply by a million. Note that sometimes the parts per million may already be provided to you, and you might have to find the mass of solute that corresponds to, in which case you have to cross multiply just like we did with the molarity problems. So just use this equation, plug in, and solve for the unknown. Be sure to note what's given in the problem. You should always be given a solution's mass or the mass of the solute to find parts per million, or you may be given the concentration, and one of these two values will be given, and you have to solve for the unknown. Hopefully this was helpful, and thank you for watching.